these kinds of thick mugs, these thick, quarter-inch thick mugs, are still available. So, so that might be happening just for fun. Going to probably put the ADL logo on some mugs and put them somewhere, maybe over on my Etsy store, something like that. We'll see. We'll see how that goes. Speaking of which, I actually had a sale on my Redbubble um, store, and it was a pretty big one too. It was a big. I I think they got some kind of tapestry or something, and it was actually um, uh, the tapestry that they uh, bought is actually what I call a tapestry. Um, I wonder if I can find it on this machine, because we can just start there, because I just like to show off art sometimes. I think it's called. Okay, so I'm going to share my screen here. So hope everybody's doing well out there. We're getting the ball rolling really quick here today. Sharing my screen already. Let me check the chat. Oh, Tom, hey. Bobby, nice to see you. Yes, I think what you're doing with Music from the Hearts of Space, I think that's awesome. Uh, Sorry I couldn't stay longer, but had to get some chores done, and that included getting some dinner done. so, so I took care of all those things, and but yeah, that's you know I came in, I think about maybe like halfway through the John Siri song, and oh man, it just put me right in the mood, right? I think it's called Art Astro over on Redbubble. We found a person that matched Art Astro, right? View there. So I just wanted to show you what they bought. So I don't. I'm not necessarily my my site, but I have these things that I call orbital tapestries, and I'm gonna get my smartphone running here with the with the live stream on the smartphone. Yeah, okay, there it is. So the one that they got, that they put onto what Redbubble calls a tapestry, is this one. They bought that one. So I think that's pretty cool that somebody likes that. Oh, and spent a pretty sizable chunk of change uh, to get that. So yeah, this artwork is created using the orbital data of the four Galilean moons of Jupiter, and those motions, right? Those motions, and I just my contribution is I find interesting color combinations, which in a lot of cases um, uh, Well, all of this artwork is created with software, right? So I cannot draw. Uh, I I just can't. You know, by hand, it's like I can't I can't do what is in my head, right? I can't do it by hand. But I can write a program, and I can tell a computer how to draw. So yeah, all of this is written with computer software, computer code, but it uses astronomical data to make the actual drawings. So yeah, somebody actually thought that that was good enough to buy. So thought that was pretty funny. Uh, I think I set I set a couple of these shops up last September, and this is um, this is the second sale that I've had. So the first sale was a sticker, one sticker, uh, and then this, and then this, and this cost a substantial amount more than a sticker does. So yeah, I thought that was pretty interesting. That somebody would actually do that. Um, so yeah, here's just a few of the other ones, all under the same category. Actually, all using the same data. So there it is on a on a pillow, right? Which is kind of not quite sure why. Yeah, see, this can. Oh, that's not it. Product available products. So you see, Redbubble is such that you can um, uh, y- you can put this pattern on pretty much anything, right? You can put it on a clock. You can put it on a stupid mug, right? Put it on handbags and tote bags and stickers and greeting cards and all of that, right? Anyway, yeah, I just thought that was cool. So, but yeah, uh, as I said, I have determined that these mugs can be gotten. So, yeah, you never know. All right, I'm going to stop sharing for a minute, get back here, take another cheers. I uh, speaking of sports, yeah, I'm not really a sports fan. Um, as as a kid, I I played. Um, well, I tried uh, baseball and basketball, and wasn't very good. Um, played soccer, played soccer, and I think I could have been pretty good at that. Um, I Yeah, I mean, I was on a different rocket, so I really didn't put heart and soul into that too much. But once we found a position that I was good at, uh, it was really fun, and I never felt really tired or worn out or anything. Although being uh, well, the position that I ended up doing really well at was right wing. So I was a front position, which means you are running. You are running for 45 minutes, and then you take a break, and then you run again for 45 minutes. You are constantly running. Um, so yeah, run for an hour and a half, and not really be worn out or tired or anything else because it was just so much fun. So yeah, right wing, that was cool. Um, uh, uh, so, uh, but yeah, if I were to watch a sport, though, the sport that I really enjoy watching because for I cannot figure out, I cannot figure out this sport, but and I'm not really into um, I don't like seeing people getting hurt, either fake hurt or real hurt, right? Um, now there, you know, I've got some exceptions to that, and that one of them, at least, is rugby. Rugby. I really, really, really enjoy all forms, all forms of rugby. Um, it's but it has me stumped. It has me totally stumped. I don't I don't understand any of it. None of it. I cannot figure it out. And I mean, I tried a couple of years ago to to uh, um, to watch, like maybe like an hour every day, and I did that for at least several weeks. And for the love of me, I cannot figure out I cannot figure out the rules of rugby. Now I know the different leagues have different rules, but the only thing that I can really get out of rugby and understand is the rules have at least one characteristic, and that is the rules are there for the protection of the players so they don't get hurt. Because, um, as you just pointed out, Atta, it's a brutal sport. But um, I think I think it looks. I don't know. I think sometimes it looks a lot worse than what it is because these guys. I mean, that's the really amazing thing about rugby is that to me it looks chaotic, right? It looks like nobody has a clue, right? They're just randomly, you know, doing whatever they're doing, right? But I know, I know that it is extremely organized and extremely orchestrated, and everybody knows exactly what their part is because it is so tough, because it's so rough. These guys have to be really careful, really, really careful. And those rules, I think, for the most part, um, are for the protection of the players. The other thing that's really, really fascinating to me about rugby is how involved the what do you call them, um, uh, what do you call them, uh, the other guys on the field who are watching to make sure that everybody follows the rules. Who is that? Who is that? Referee. Yeah, yeah. Sorry. Uh, yeah. So the referee is like incredibly involved. I mean, he is right in the middle of things, watching, right? Watching to make sure that they don't poke their eyeballs out or you know uh, break each other in half. Because I mean, any of those dudes, right? Any of those dudes could kill any of the other ones, right? I mean, easy, easy. These are tough, big dudes, and uh, and I like the action, right? I mean, really, really, it makes American football really embarrassing. Like really embarrassing. It's like we do we do what? Compared to rugby, it's yeah. I mean, I don't think with rugby there's any padding at all. Maybe in one particular area, maybe. Um, but other than that, I think a lot of them do wear some kind of headgear. Don't they wear some kind of headgear? I'm not quite sure if it's to make sure their head sort of stays together when they smash each other. I'm not sure. I'm not sure. But yeah, so for me, it is definitely rugby. Rugby, I definitely, if I'm going to watch a sport, I will watch that. Um, if there's tennis on, I'll watch a little bit of that. Um, if there is soccer on, I'll watch a little bit of that. Um, but none of these things, I will, like actively be like, oh, time for the rugby match. I gotta go. Bye. Uh, no, I don't think it's gonna do that. Yeah, NASCAR is really, really popular. Yeah, I like the history of NASCAR. I think um, that to me is the best part. Uh, is actually the history of all car racing, right? It started with the bootleggers that if you could drive faster than the cops, then you could get away, right? So so um, yeah, they would take these stock cars. They would take these stock cars and build them up, right? Build them up so they can handle a heavy load and not look like they're holding a lot of weight, and also be able to move faster than the cop cars. And so yeah, that's where all that started. And so that aspect of things I really really like. Um, I was into watching car races for a while, and I guess mm, I guess I didn't I couldn't get past the fact that even on Grand Prix, right? They would just go around and around and around and around and around, and I for some reason I couldn't and still can't really get past that. Um, and I'm glad that there are those that can appreciate it for something else. But yeah, I can't in terms of race overall, be it a running race or a biking race or anything else. Now, the Tour de France is neat, right? Because it isn't just around and around and around, but it's a lot of forward, forward, forward. So it's sort of the same thing, every single day. The, you know, of course, there are differences, um, but for the most part, the guy is sitting on a bike and he's pedaling. That's pretty much what they do, and it's same with car races. The guy is uh, sitting there behind the wheel, turning the wheel and pushing on the gas. And That's about what they're doing. So, and that's very, very cool. And I know that there's much more to it than that. And that's where you can start appreciating all of these things. So, yeah, um, whatever you're um, into uh, uh, I totally support it. Totally. If you're having a good time with it, who am I? Cheers. Yeah, cool. I think I think uh, the idea of taking your smartphone, right, to a tennis event, say, right, and setting it up on a tripod and broadcasting it on your own channel, right? I think it's great. I think it's cool, and um, everybody can watch it if they want to, right? And but if everybody's doing this, and not everybody's going to, but if there's a substantial amount of people doing this, how do you make your service any better? I don't know. You know, add add commentary, add I don't know. The variety. I don't know. Okay, so auto rally. Okay, cool. Yeah, that's as I said. I have a problem seeing people getting hurt, and so even crashes like that. I'm too either sympathetic or um, empathetic, right? I sort of feel it, and it's like, I don't want to feel that. So yeah, I just sort of stay away from those kinds of things. So well, yeah, of of course, Totterbert, of course. Cheers. All right, well, cool. All right, I think I've rambled long enough on that. Uncle Bill, who I don't know. Uh, uh, um, Uncle Bill, I don't know if you're in the chat or not, but you posted a pretty cool paper over on my Discord channel, or Discord server. Um, so I just wanted to talk a little bit about that. Not again, this is another case where I'm going to sort of use a paper to talk about something sort of else. Uh, so yeah, if you're interested in anything over there, take a look at redbubble.com and look for Art Astro. All right, so just do a search for art. Let's see, I can type it in the just all one word, Art Astro, like that. And yeah, if there's anything interesting there, uh, go for it. I I don't know if I don't know if the prices are any good. I I do know I've heard some very very good things about the quality of all of these items. So you know, uh, not having any of my own, I can't really vouch for them too much. But you know, I've I've looked at a few reviews of Redbubble, and people seem to be pretty pleased. So yeah. But I've got you can go. Sorry, I said I wouldn't do this, but I've got different different categories here too. Right, I've got mandalas. I don't remember how many I've got over here. I've just got a couple. Yeah, just a few. Anyway, take a look at those if you want. It's fine. Let's go over to my Discord. And because the actual paper that Uncle Bill sent over is awesome, right? And I encourage you all to take a look. Take a look. Yeah, Totterbert, I had that site up since like September or so, and I haven't been incredibly active on it. And actually, I almost forgot about it until I had a sale the other day, and it's like, oh yeah, I forgot about all those things. So yeah, I'm just bringing it up. Uh, take it as you will. Most people seem to like my artwork. Let's see. I think he put it under science. Yeah. So we'll pull this up. Yeah. Well, the whole thing, all the excitement, um, is about the object, so-called object, at the center of our galaxy. There seems to be something there, right? You can watch the little stars zip around it, and there seems to be something there that we can't see. So, everybody's pretty excited about that. And um, so um, these folks have um, they've taken uh, a bunch of data that has been taken over the past, well, from 1995 to 2005, and then some additional stuff a little more recent, like 2013, 2014, I think. And these are images, infrared images. Now, not the thermal infrared, right? Sort of the near infrared. I think around like two microns or so. So 20,000 angstroms. Um, yeah, yeah, 2,000 nanometers, 2 microns, 2 micrometers. So, and they took a bunch of image data. Most of it was what's called speckle images, and that's actually what I sort of wanted to focus on a little bit, because that's actually uh, one of the areas that I worked on quite a bit when I was at the University of Arizona. Was you know uh, under the umbrella of high resolution imaging. So I was part of the adaptive optics group, and I was also sort of partnered up with a couple of people. Uh, let's see, one one person at Stewart, one person at Kitt Peak, and another person at, where was he? I want to say Caltech, but I don't remember exactly where he was. Anyway, partnered up us three, and we're working on the post processing of images to you know sharpen them up, give them higher resolution than what's possible uh, just using a telescope. So so I was actually working on both sides of that, right? I was working on the input side using adaptive optics, um, and I was working on the output side, taking um, images and trying to improve them, right? So, and one of the ways that you can do that is with this technique called speckle um, speckle imaging. And what that involves is taking a series, uh, sometimes a very, very long series, of very, very, very short exposures. Um, you know, and we're talking about, video rate exposures. So, 30 millisecond, 50 millisecond, maybe, um, 100 millisecond, tenth of a second exposures. So, the slowest you're running is like 10 hertz, right? And the fastest you're running, well, as fast as you can go. So, uh, the reason why that's done is because the atmosphere is uh, uh, is in constant motion, right? It's in constant motion. There's you know convection going on. Hot pockets of air going up, cold pockets of air coming down. You've got sideways wind. You've got moisture. You've got dirt. You've got turbulence. All of that, right? And all of that affects what we call the seeing, and that's sort of a well, it's not exactly a subjective thing, but I mean, it's a measurement that tells you how transparent the atmosphere is, how stable is the atmosphere. And so what I sort of envision, right? And here I'm going to go back to my ugly mug because that might be more interesting than staring at an abstract. Well, I got to do that. There we go. Okay, so what I think of is, imagine that the entire sky is filled with these sort of strange shaped lenses, right? So clear lenses, um, but not necessarily shaped like a normal lens, right? But oddly shaped, sort of having having a size, right? But not necessarily being concave or convex, being bumpy, um, being perhaps even tilted, right? So you're not seeing all these lenses face on. Sometimes, you know, not only are they bumpy, but they're tilted like that. Okay. So then imagine imagine shining a light. How about this? Imagine shining a laser beam th- through that. Okay. So So you're standing on the inside of this dome of these weird, clear lenses, right? And somebody on the other side is shining a laser beam through at you. Okay. Well, as the laser beam goes through that those weird lenses, right? The path of the laser is going to change, right? And it's actually going to, enter sort of, tangentially to this uh, array of weird lenses. Um, but as it passes through this, right, it's going to be bent around, who knows how, right? I mean, in general, it'll be bent in a certain way because each of these lenses does have a general shape and a general size that are more or less all the same, right? Um, but if you shine a laser beam through that beam is going to be, distorted and moved, maybe even spread out, all kinds of things. Okay. Now imagine that this whole lens array is moving, right? Is moving around, right? Pretty fast, pretty fast. But the the time that it takes for like one of these lenses, and I'm going to start, I'm calling them cells. Okay. It's, yeah, you can call it a cell, you can call it a lens. I'm going to start calling it a cell. Um, so the time that it takes for this cell to sort of move one of its diameters, right? So, from here to here, right? Just one diameter. The time it takes for that to happen is about uh, I want to say between 25 and 40 milliseconds. Um, Maybe it's a little bit more, but not much. Now, um, due to various weather conditions, right? The sizes of these cells can either be very small or very, very big, right? So they can change in size too, and that has more to do um, with weather than anything else. Um, uh, so, uh, so having small cells that are moving around means that laser beam, right, that is coming at you, um, is going to be distorted a lot more and a lot faster, right? Um, if you've got a large cell, that laser beam's still going to be distorted, but it's going to be moving a little bit slower and, yeah, more of an area. So, if the laser beam is going like through the exact center, right, like the center of my hand, um, then as you move it around, you see if it's doing this, right? If each of these little cells is just sort of moving like this, if you pay attention to the center of my hand, there's not that laser beam is still going through that cell, but it's not going through a lot of bumpy stuff or messed up thing or anything like that. Um, so that's exactly what is happening um, in our atmosphere. It's well, it's not exactly. I mean, it is a metaphor, but it's pretty close to what's happening in our atmosphere. Our atmosphere is acting like a lens, um, and we've determined that we can actually see it as this very, very complicated array of moving lenses. Um, and that's what causes our seeing. And those lenses do two things. They change the amplitude of the wavefront, and they change the phase of the wavefront. So the amplitude of the wavefront is just the brightness. So that's why when we look at the stars with our eyes, we only see changes in brightness, right? And that's called scintillation, and that's twinkling, right? That's exactly what that is. That is amplitude modulation of the starlight, which is basically like a laser beam. Um, it's a point source, right? Um, and so that is the amplitude modulation. We also have phase modulation, and that is what 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 will cause the image of the star or the laser beam to sort of appear to move around or to be spread out. Both of those things occur, and they occur on time scales, as I said, of around, I want to say like 40 milliseconds or so. So what is that in hertz? 0.04 seconds is 40 milliseconds. I just have to invert that. So that's 25 hertz. Yeah, 25 hertz. Twenty-five hertz. Yeah. So so yeah, that so phase modulation will cause the image of the star to move, um, and also potentially sort of spread out into a number of different blobs. Um, and so each of those blobs, each of those little blobs, is what's called a speckle. And one name is as good as another, so that's just fine. That's just fine. But the cool thing is that say that your say that the size of the lens up in the sky was like 10 centimeters. Okay, 10 centimeters, 10 centimeters, finger to finger. Okay, something like that. Okay, now, so that is the size of one cell that's going to, you know, do something to this image of the star as it moves through this cell. As you can see, in my eye or your eye is much smaller than that. Much smaller than that. So as the cell moves across your eye, you're not going to see any distortion in terms of position. You're just going to see it change in brightness. That's it. Okay? But if you have an entrance pupil that is larger than this size, right? How about a 20 centimeter 20 centimeter aperture? Okay, that's a 8.5 inch or an 8-inch telescope, right? 8-inch scope is about 20 centimeters or so, right? So if these little lenses are about half that size, then you can actually expect to see 4 speckles with an 8-inch telescope, and each one of those speckles is the highest resolution image that you can get of that object. So if you were to do a long exposure, right, what you would get is all these speckles would sort of add up, and you get a big huge blob like this. But if you take a short exposure that sort of freezes the atmosphere, right? Freezes it, right? Um, what you'll see, even in an 8-inch telescope, is 3 to 5 um, points, right? There'll be a brightest one, and then there'll be a few others, right? Up to 5, I would say. Um, yeah, I mean, it depends on the seeing, right? If the seeing is really, really bad, then those cells are really small, right? Which means that you'll actually see more speckles in the same sized telescope. So in that is one of the cool things about speckle interferometry, is that you actually want um, and almost need bad seeing in order to fully utilize um, the techniques that can be employed to improve those images. Because ultimately, what you want is a nice long exposure at the highest resolution that you can do. And the cool thing is that yes, we can, even though we're taking short exposures, if you're taking it at video rates, okay, you're talking about thousands and thousands and thousands of images that you can all add, right? You can add image 1 to image 2, and then image 3, 4, 5, 6. You can add all those up, right? And so one of the techniques, and the simplest um, speckle interferometry technique, is a technique called shift and add. Shift and add. And so what is done, and oh man, let me. I don't think I don't think that there's a really good example anywhere quick, but let me poke around a little bit. I want you to see what a speckle image looks like a binary star. Just so you can get an idea of what I'm talking about, because it's hard, it's really hard to visualize this kind of stuff. Binary star. Let's see if there's any images. Well, oh, okay, here we go. It's really hard to see. I don't know. It's not there. Oh, oh, it's some kind of paper. No, I don't want that. Well, that sort of sucks because we can't really see what we want to see. Let's do this. Is it under settings? No, where do tools, large. Well, see if we can get you something here that's halfway decent to look at. Getting further and further away from what I want. Dang it. Know that you don't mind inviting you, but you will shut down after the show, right? Yeah, sorry about that, Tom. Sometimes the brain and the microphone just don't match. Yeah, I'm not seeing anything now gonna make me download a stupid paper. Okay, well, yeah, this is lame. I mean, this is all correct stuff, but yeah, I wanted to show you something a little better. But I'm not quite sure why there's two here, one, two, and then I'm not quite sure, but I guess you sort of get the idea, right? Is that each of these little individual dots here really is the individual star. This is what that uh, that weird shaped lens does to a laser beam spot when it's distorted. This is a distortion, and but as you can see, there are these little dots. You see them? See these little tiny things like that, and that, and that, and that, and they're all weird looking too. But um, and this is what I'm not understanding. This last convolution keys. Yeah, this is just a really old paper. Anyway, so the idea with speckle interferometry is that I'm gonna stop sharing. So the idea with shift and add is that you take a specklegram like that, and you find the brightest one, and you look at the first image, right? You look at the first image, and there could be thousands of them, tens of thousands, hundreds of thousands, right? You look at the first one, and you find the brightest speckle, and you take the whole image and you shift it such that that bright speckle is right in the center, right? So you sort of have to make a slightly bigger image, right? Like this whole thing. And then inside of that, you'll take your actual data and you'll find the brightest pixel in there, and then you'll take that whole frame and go so it's right in the middle. Then you'll take the second image and do exactly the same thing. You'll find the brightest, the brightest speckle, and move it into the center and add it to the previous one. And so you do this for all your thousands and thousands and thousands of images. And what pops up is very, very interesting, right? If there's a binary star in there hidden, right, because it's so blurred out that you really can't see two things, you just see one. But that pattern is in there. You just have to somehow bring it out, add some contrast. So so that's shift and add, and that's extremely easy to do, extremely fun, and I was reminded when I read this article about the fact that I have a bunch of images of Jupiter's moons that I recorded. Don't remember if it was the last time I did a telescope thing or if it was the time before that. But I've got several minutes worth of images, and those images are speckle images. I was very, very clearly seeing two to five speckles um, looking at the moons. So I was definitely seeing some speckle stuff. See you later, Ata. Take care. No problem. Yeah, high resolution imaging I thoroughly enjoy. Yeah, it is fun. It is cool. It is very, very cool. So that's shift and add. There are other ways, and actually in the paper they talk about two different ways. Um, uh, Shift and add, um, and then holography. And holography is for another show. So I'm not going to get into that here at this point because wow, it's already 2:59. There we go. 3 hours UTC. It's totally amazing how time flies. Time absolutely flies. So holography is also very, very cool and actually more powerful. You get better results um, in terms of signal to noise with holography than you do with shift and add. Shift and add will get you pretty far though. It really, really will. I need to grab the images that I took, the video that I took, and run that through shift and add. See, as a programmer, right? As a programmer, I can I I can write that code. In fact, I already have that code. I've already got it, but it's code that I've written, and I can modify if I need to in order to suit this particular need. So yeah, I'll have to figure out. I've got it in. I think it's saved. It's stored in AVI. It's either AVI or MP4. So I need to convert that to, like FITS files or text files with just a list of numbers, whatever it is. All right. So, oh, I think yeah, and it's a pretty interesting paper too because they're trying to get a handle on what is going on in the center of our galaxy, and now that they can look at and observe and track individual stars, zipping around, vroom, vroom. Um, they're I guess they're getting a pretty good handle on the mass of the object. Um, you know, if you just look at the orbits and it's like, okay, this is what they're doing. If simple Keplerian uh, rules here, then that mass has to be X, right? And it's some millions of solar masses, some millions. So yeah, just absolutely amazing. So you're not really here. All right. Cool. Good. 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 It's. I think what you're doing on on Twitch over there is very very awesome. I hope to join it at some point. I think Twitch is probably. Um, uh, I think it's just well, it's slightly different crowd, but it's also I think in a lot of ways maybe it's a bigger crowd. I don't know. I don't know. But I'll probably try to simulcast. I don't know. This is going to be the format for a while. By the way, I got a notification that my camera was delivered to my mailbox. However, when I went to check my mailbox, there was nothing in it. So so yeah, I was when I got the notification, it's like, well, cool. I'm going to be able to mess with that before today's live stream, and then if all goes well, if it seems to work, then I'll be able to use it on tonight's live stream. But no, no. So this is a rural area, and so one must give well one should give certain allowances regardless of location. But out here, at least how I am, I'm sort of like, well, you know, we'll give it a little bit of time. We'll see if it pops up. So because it could, I don't know, I don't know, and yeah, I guess if there's any kind of problem where it's lost or anything, it's like, well, it's lost. But yeah, never had any kind of problems with deliveries or anything, so I don't expect there to be anyone here. Pro- you know, those kinds of things. It's like maybe when it hits the post office, or maybe when it hits you know uh, the hub, right? Uh, it gets posted as delivered, where it's still about a day away. Uh, from happening. So yeah, if it doesn't show up in the next few days or so, I'll try to figure out what I can do if anything, and then go from there. So, all right, I think I am going to get out of here. Um, I think I think Bobby, I am probably going to crash and burn again, most likely, most likely. So thanks, but I will gonna have to pass this time. This time, but yeah, keep it up. Um, I think it's great. I think it's a great um, uh, place to do those kinds of things. I think it holds some interesting promise, and I just think it's cool. Right. So of course I'm talking about rabbits, and I think I've got. Do I have a link in the description down below yet? Um, uh, yeah, I'm not sure. Um, But anyway, great place to sort of share uh, audio, video, whatever. It's pretty cool. And yeah, I'll give the post office at least a couple more days because you know everybody's a slacker. All right, I'm gonna get out of here then. So yeah, hope you like that short and sweet of speckle interferometry. It's very cool, and it can be done with small scopes. The one downside to speckle interferometry in general is that you really can't um, do this with faint objects. Um, they were talking in the paper that they were looking at a K magnitude, which is infrared, around 2 microns, 2.2, I think. Um, they were using the Keck they were using the Keck 10-meter telescope to look at a magnitude 14.6 uh, star. So they have to stick with pretty bright objects. You can't do anything faint because you got to take such short exposures, right? 30, 40 millisecond. I think they were doing 100 millisecond exposures in in the infrared. They can sort of get away with that a little bit more. But so that's the one downside of speckle interferometry is that you can't go faint. Although 14.6 K band is pretty faint, that's pretty good, but you have to get time on the largest telescope in the world. So good luck with that. All right, take care, everybody. I will see you on the spin tomorrow. Hit the thumbs up if you don't mind. Hit the thumbs down. That's fine too. Reaction is what I'm after. Um, subscribe if you wish. Hit the notification. Spread the word. Spread the word. We're trying to find our core group, and around the world, I think it's pretty big. I think there's at least a few hundred of us, at least, at least. So we just got to find them, the ones who want to share a common passion for all things astronomy. Yeah, astronomy daily live, 2 hours UTC every single day, unless I say so. All right, take care, everybody. Peace, cheers, and all that. I will see you on the spin. A little less than 23 hours. Bye.